Woohoo! Starting the biogeochemical cycles. Bio, of course, means life, geo, earth. And we are talking about the cycling of matter. Remember, matter cycles, energy flows. Ding, ding. Okay, so let's start with the water cycle. Most of you are familiar with this. Everyone's got to be familiar with this. But I'm going to point out to you again what I said the other day, because sometimes we do this, something that's obvious, but it's wrong. And we say that because of pictures like this, you think that when the water evaporates, it all evaporates up into the clouds, but it doesn't. It evaporates all over. It's all over here. It's just the clouds where that moisture condensates, and then you have precipitation from there. But there's that water vapor. Once it evaporates, it's all around us. It's not just up in the clouds. And so you have the sun, the energy, solar energy that will heat up those water molecules, and they change their state. They break that bond, and they change that state from the liquid to the gas. So you have this, of course, evaporation, and it's going to come from the seas, or you have evaporation that comes from the rivers, fresh water, lakes, anything like that. And then this evapotranspiration, and that's the water that's coming from the plant. So all the plant material, you have transpiration that takes place and evaporation from that. So you have this cycle. It just goes up and it comes back down. All right, moving on to the carbon cycle. Remember, we have to have carbon dioxide in order to be able to, well, not we, because we don't photosynthesize unless you're having a bad day. That would be weird. All right, so, although green's not really necessarily a bad color, it just depends on the level of tan that you have, but All right, moving on. So, we have this carbon dioxide in the atmosphere that, of course, plants use to photosynthesize. And then you have your primary consumers, your herbivores that eat those plants. So that carbon is transferring over to the plant. And then you have a secondary consumer that eats the primary consumer. And you can also have carbon put up into the atmosphere as a result of cellular respiration. So as that CO2 is given off, it goes back in the atmosphere. You can also have it from detritus. Remember, we said that detritus and detritivores ate dead organic material. And so detritus is dead organic material, and detritivore, devour, eats the detritus. So dead organic material from any of these levels, and then the detritivores eat it, and there is there is CO2 put back in the atmosphere as a result of that. Now there's also this over here, wood and fossil fuels burning. So these CO2 is also released from those as well. And so we have this great cycle that goes on around. Again, we need CO2, and all of these different materials will produce that CO2. Let's move on to the nitrogen. Nitrogen's just a little more complicated in a sense. Okay, so the nitrogen cycle, we have to have atmospheric nitrogen, and the majority of the nitrogen in the atmosphere is removed from the air by water. Water is the universal solvent, so nitrogen gas is dissolved in the rain or the snow. So the nitrogen in the water is mainly consumed by what's called the nitrogen-fixing bacteria. And if you follow it along, so here's atmospheric nitrogen, and then we have nitrogen-fixing bacteria, and my mouse is not cooperating. We have nitrogen-fixing bacteria in these root nodules of legumes. They're also in the soil. And what you could see both of these, what they convert that atmospheric nitrogen, the N2, into NH4. Because remember, it combines with water, which is H2O. Oxygen's given off, and then you have your NH2. All right, then that ammonium right here, that once it's converted to that, we have this ammonium, and that ammonium is consumed by this nitrifying bacteria, and it's converted into nitrite, and then ultimately into nitrates. And this whole process here, see how it's called nitrification. So here, going from atmospheric nitrogen into ammonium is ammonification, and nitrification is going from the ammonium into the nitrates. Okay? So again, think logically about those terms. Ammonification, you're doing something with ammonia. Nitrification, you're making the nitrates. The plants themselves eat the nitrates and the ammonium, but not the nitrites. So the plants don't eat the nitrites here. They're not usable. So these nitrifying bacteria convert the nitrites into the nitrates so the plants are able to use them. And and then you also have bacteria that can eat the nitrates as well. All right, so there's that cycle. They consume the nitrates. They break it down into these right here. They break it down into the N2, again, going back into the atmosphere, and oxygen gas. So this is called denitrification. That makes sense, right? We're denitrifying it. The plants are eaten by the animals, and then the nitrogen travels all through the food chain. When everything dies, the body decomposes. So when it dies, it decomposes. That's what we have here. And creates ammonia. This is why they stink. This is why they don't smell good. Because the ammonia, because they are converted into ammonia, and ammonia doesn't smell good. The ammonia is converted by the bacteria into the ammonium. So dead ammonia decomposers, and then we have ammonification, so it goes back, and then it goes back through this cycle again. Some nitrogen's also released by animals in their urine, and that also undergoes ammonification. I love the nitrogen cycle. All right, phosphorus cycle, another chemical that's needed, and phosphorus is initially a component of rocks. So as these rocks break down over time, that process is called weathering. So that's going to break down. You can see this rain is hitting those rocks, wind hits the rocks. It just breaks the rocks down over time. And the phosphorus is released then into the soil. And some of it dissolves into the rain as the rain passes through the soil. So you have rock, the phosphorus in the rock breaking down into the soil, the rain, and that phosphorus leaches then into the soil. And it makes its way, ultimately makes its way into a body of water. And like lakes, oceans. In lakes, it's available for plant material in the lakes here. In oceans, for phytoplankton. And it's used to make organic compounds such as phospholipid. Remember, we had that in the phospholipid bilayer. So phosphorus is required. It's an essential element. This is where we're getting it from. So you have this whole cycle. It's also in DNA and RNA. Those sides to the ladder are alternating sugar phosphate groups. Plants that are also producers retrieve the phosphorus from the soil. Sorry. Oh, I bet all of you are yawning now. Okay, so they retrieve the phosphorus and use it to make organic compounds. So the plants need that phosphorus, and so they get the phosphorus from the soil, and they are able to make organic compounds. And then, of course, when they die, then decomposers, when plants and animals die, decomposers break down those bodies and return the phosphorus back into the cycle. So you have it breaking down from the rocks, and then as the rain washes it down into a body of water, so you can have it moving along in the cycle aquatically or terrestrially through plant material and animal material dying and decomposers breaking it down. Whoops, let's go back here. Now there's one last section that the notes talk about, things that affect these cycling rates. Temperature. Temperature has a big effect on it. The higher the temperature, the faster the recycling. Think about the tropical rainforest. The warmer temperatures, that organic material is going to break down faster. The lower, it's going to be slower, the recycling. And so think about the tundra. And just think about, when it's cold, I don't want to move very fast. But when it's hot, I am running around having fun. Well, not if it's real hot, like the desert, 120, not so much. Okay, so I want you to write one note at the bottom. Oh, golly, sorry for that yawn. Please write one note at the bottom. And I want you to write that carbon, nitrogen, and phosphorus, so 3 of these right here, 3 of these cycles, they're needed to make the macromolecules, sugars, lipids, nucleic acids, and ATP. All right? And so all of those, these that are cycling, and of course we need oxygen and all of the hydrogen from the water cycle as well. But these other elements are absolutely needed for all the components, for all these macromolecules that we studied. You know, we cut those babies up and made those big models and everything. It was such a fun time thinking back to that. All right, enough. Have those notes at the bottom. Have a